Okay, here we are with section 6.3. The name of this lesson is called Tests for Parallelograms. Sounds a little weird, but let's explain what it is. In yellow right here, this is a theorem that we did in the last section, which is section 6.2. It says, if a quadrilateral is a parallelogram. Now, that's a key right there. If a quadrilateral is a parallelogram. So what do we start off with? We start off knowing that, let's say, for instance, this right here. We start off knowing that it's a parallelogram. So we know it's a parallelogram, so what must be true about it if it's a parallelogram? In this theorem, it says then its opposite sides are congruent. Look at the difference between the yellow one and the green one. This says, if both pairs of opposite sides are congruent. So it's actually switching. It's kind of like the converse. It doesn't call it the converse, but it kind of is like the converse. It's basically switching the if and the then around. It says, if its opposite sides are congruent, so let's mark that. If, now I don't know it's a parallelogram. It doesn't say if this object is a parallelogram. It just says, if you have a figure, okay, and if both pairs of opposite sides, all right, that's one pair of opposite sides and they're congruent. And here's another pair of opposite sides and they're congruent to each other. If both pairs of opposite sides of the quadrilateral, right, so you start off with four sides, and if you know that both pairs of opposite sides are equal or congruent to each other, then what can you say about it? Then you can say that the quadrilateral is a parallelogram. Do you see the difference? This one said if a quadrilateral is a parallelogram, that was the if part of it. This is the then part of it. Then the quadrilateral is a parallelogram. You're basically switching it. So you don't know right off the bat that it's a parallelogram. That's why they call this a test for parallelograms. We're going to test. We're going to see if this figure is in fact a parallelogram depending on what is given to us. All right, so if they gave me this figure right here, A, B, C, D, and they said, is this a parallelogram? They mark the stuff equal, all right, and you don't know it's a parallelogram until you look at the given information. So could I say that this is a parallelogram? Well, this theorem says if both pairs of opposite sides are equal to each other, then you can go ahead and say that this quadrilateral is a parallelogram. So yes, that passed the test. All right, we're going to have several criteria to see if it's a parallelogram or not. And so this is the first one. If both pairs of opposite sides are equal to each other, congruent to each other, then I can say that it's a parallelogram. Okay, now that we saw that, we're going to see the next one. This kind of falls in place with the other section. Again, this is very closely related to the section 6.2. Look what the old theorem said from 6.2. The old theorem said if the quadrilateral is a parallelogram, okay, so now I am saying that this is a parallelogram, what else must be true about it? Then its opposite angles are congruent. So if I know this is a parallelogram to begin with, then I could say that D and B are equal and angles A and C are equal, if I knew it was a parallelogram. But what if you don't know it's a parallelogram? What if they just give you some information? What if they tell you that A and C are equal to each other? And what if they tell you that D and B are equal to each other? Is that enough information to say this is a parallelogram? Well, according to this theorem, it is enough information because it says if both pairs of opposite angles of a quadrilateral are congruent. Are they? Yep, that's congruent right here. This is congruent right there. Then what can you say now about this quadrilateral, this four-sided figure? Now you can say that this is a parallelogram. Remember, they didn't tell you it was a parallelogram to begin with. They just gave you a four-sided figure and they told you some stuff about it. And you will have to do a test to see if it's a parallelogram. Does it pass this test? Absolutely. This is the theorem, this green one right here. That's the theorem that says that this is a parallelogram. If both pairs of opposite angles are equal, then it's a parallelogram. Okay, let's look at another one. Again, the original theorem, we'll call it the theorem from 6.2, said if the quadrilateral is a parallelogram. So again, I'm looking at this, and according to this theorem right here, they're telling me that this thing right here, ABCD, is a parallelogram. So if it's a parallelogram, what else might be true about the parallelogram? Well, the diagonals must bisect each other. So if it's a parallelogram, then the diagonals bisect each other, which means that AE would equal EC, and that DE would equal EB. Again, what did we start with? We started off knowing it was a parallelogram. and I've got some diagonals in here. What must be true about the diagonals? They must bisect each other. So these two segments are equal and these two segments are equal. That was the old theorem. What's the new theorem on this lesson? What is the test to say that this is a parallelogram? Now, on this theorem right here, we're looking at it a little bit differently. We're looking at it as just a quadrilateral. We don't know it's a parallelogram right now. We have no idea, but we do know that it's a quadrilateral, and that's all we know, except for about the thing about the diagonals. Let's look at it. If the diagonals of a quadrilateral, all right, so here's my two diagonals of a quadrilateral, don't know it's a parallelogram yet, but if I know that those diagonals bisect each other, now according to the information that I have here, do they bisect each other? They absolutely do, because this diagonal has split this one into two parts, and this diagonal has split this one, BD, into two parts, two equal parts. So yes, they did bisect each other. So what must be true about ABCD? What must be true about this whole thing right here? Now again, we didn't know it was a parallelogram to begin with, but by seeing that the diagonals bisect each other, then that tells us that this thing, ABCD, is a parallelogram. So hopefully you see the difference between these, okay? We're kind of seeing the same thing over and over again. This is the old one. Starts off saying it's given that it's a parallelogram, then we can say that the diagonals bisect. This new one today, we're saying, okay, I see it's a quadrilateral. I see there's four sides, but I don't really know if it's a parallelogram or not. How can I tell? Well, you look at the given information. If the diagonals bisect each other, which they do, then guess what this thing is? Then this thing must be a parallelogram. Now this one's a little bit different. I didn't put 2 here, okay, because this doesn't really relate to one that we learned in the other section. This pretty much kind of stands on its own, but it has definitely some similarities. So let's take a look at it. It says if one pair, not both, if one pair of opposite sides of a quadrilateral, okay, so right now, again, we don't know it's a parallelogram. Kind of looks like one, kind of think it might be, but I don't know right now. But it says if one pair of opposite sides of this quadrilateral is both parallel, oops, keep doing that, don't I? Let's fix that, okay? If one pair of opposite sides of a quadrilateral is both parallel and congruent to each other, okay? If one pair, not both, if just one pair of opposite sides is both parallel and congruent, so I can pick either side. I can pick either this one and this one because they're opposite, or I could have picked this one and this one. It doesn't make any difference. Let's just pick the top and the bottom one. So if this side is both, let's do the parallel first. If this side and this side are both parallel to each other, is that enough to say this is a parallelogram? No, it's not. All right. Now, if I said that both pairs of opposite sides were parallel, that would be enough by the definition. But we don't know that. We don't know anything about this side and this side. But I do know that these two sides are parallel, and I also know that they're equal to each other in length. Actually, let's go back a little bit. If you think about this, it kind of makes sense. These can both be parallel, not be equal to each other. I could take this and extend it way out here, and then this side would come right here. And would it be a parallelogram? Absolutely not. It would not be. So both of these things have to be true. Not only just parallel to each other, but they have to be equal. Or congruent. That's the word we use a lot in geometry. Okay, so this is what this situation is saying. If you have a quadrilateral, don't know it's a parallelogram, but I know it's a four-sided figure, and I take one pair of opposite sides. I can either take these two or these two. And if, let's say I take the top and the bottom one, if they are both parallel to each other and equal to each other in length, then this thing is a parallelogram. And if I know it's a parallelogram, I know a bunch of other stuff now, don't I? I know that both pairs of opposite sides are equal, so I know that this side and this side must be equal. I know the opposite angles are equal right here. I know the consecutive angles are supplementary. I know the diagonals bisect each other. So if I know this is a parallelogram, then I know a bunch of stuff about this. But remember, at the beginning, I didn't know it was a parallelogram. All I knew, it was a four-sided figure, and one pair of opposite sides were both parallel and equal to each other, and that's all I knew. But according to this theorem, that's enough to say that this thing is a parallelogram. That's one of our tests to see if this quadrilateral is in fact a parallelogram. Okay, here's a simple little example that we'll take a look at. Hopefully this shouldn't be too hard for you. It says if fk is 3x minus 1, so let's mark that. We'll put that right here, 3x minus 1. Kg is 4y plus 3. We'll put that right here, 4y plus 3. That's kg. Jk, which is this one right here, is 6y minus 2. And kh right here is 2x plus 3. All right, that's the stuff they tell you. Now, what's the question? It says find x and y so that this quadrilateral, remember, they don't tell us that this is a parallelogram, do they? But they say find x and y so that the parallelogram, or the quadrilateral is a parallelogram. So I want to figure out what x should equal and what y should equal in order to make this thing an actual parallelogram. Well, look what these lengths are. These lengths are the diagonals, or at least part of the diagonals of this figure, this quadrilateral. Remember, I don't know it's a parallelogram just yet. All right, that's what I'm trying to figure out. So I do know that this quadrilateral, the diagonals are bisecting each other. Okay, I'm sorry, I should say this. If this was a parallelogram, I want to find x and y so that it makes this a parallelogram. So if this was to be a parallelogram, then the diagonals would actually bisect each other. So if the diagonals bisect each other, then it's a parallelogram. So let's make these diagonals bisect each other. That would make this equal to this right here. So JK and GK must equal each other in order to make this thing a parallelogram. So let's set them equal to each other. So 6y minus 2 will equal 4y plus 3. Subtract a 4y from both sides, you get 2y added 2, and you get 5. And then, let's see, did I put the right numbers in here? Oh yeah, I'm sorry. I was looking at a different problem. I was like, this is not coming out the way it should, but I just saw the wrong problem. So we divide both sides by 2. So you could say it's 5 over 2 or 2.5, or if you want to write it as a decimal, you could write 2.5. Technically, on a quiz or a test, if you wanted to keep it like that, I'd be perfectly fine if you kept it like this. But this is the way they have it in the book, so I'll write it like that. So if y is equal to 2.5, at least this diagonal is being bisected, because then this would equal this. Well, what else is going to make this being bisected right here? If I set the x's equal to each other, so it's going to be 3x minus 1 equals 2x plus 3. Subtract 2x from both sides, add 1 to both sides, and you get a 4. So if x is 4. So watch, the only way that this thing is going to be a parallelogram is if x was equal to 4, which would make these two segments equal to each other, which means it's being bisected, and if y was equal to 2.5. So if y was equal to 2.5, then this whole segment would be bisected. All right, so it's kind of asking the same thing as before with just a subtle little difference, okay? And that subtle difference is you don't know it's a parallelogram to begin with, but you're trying to find out what x and y are equal to in order to make it a parallelogram. You did the same type of problem in the other section in 6.2, but the wording was different, okay? The question was different. The question said, if this is a parallelogram, you are given parallelogram FGHJ, then solve for x and y. The math is exactly the same. It's just a very subtle difference in really what they're asking. Hope that makes a little sense.